Nintendo Switch. Let me show you what's going on. Alright, so we clearly have issues in the port. Those pins are bodged up in a way that could definitely cause secondary issues, if not catastrophic issues. So our goal here is going to be to, or our process is going to be, disassemble entirely, pull the port, and do some testing to see if it's worth continuing beyond that. Alright, we won't know until we get there. Okay, during disassembly we've run into something we need to take care of. A bunch of corrosion on the battery. I think we'll use our sonic brush for this cleaning. Alright, that looks pretty good. Let's get that connector too. Looks like some gunk got right in there. I'm not sure if our battery's going to be any good for us, but we'll find out. Alright. The sonic brush did a nice job on that, so we'll continue with our disassembly and go about our port removal. Okay, we have the board out of the housing and we're ready to remove the port pretty much. But before I do, let's throw up the temperatures while I set up my equipment. These, as always, these are the expected temperatures for this job. They are subject to change if the job changes. I generally don't come off these temperatures for a Nintendo Switch though. Alright, switch it back to microscope. We're going to do what we always do. We're going to low melt the anchors and the visible pins, and then we'll kind of blow it off the port. Blow it off the board. Stay away from my other stuff. On top of the iron like that. I like to climb up the iron. It's not much use up there. Very good pull. Excellent. No pull pads or anything like that. I've never pulled pads with this method unless there was already pad damage. So, okay. What we want to do here is check for any bridges, and I don't see any on here. So, if there were any bridges, we'd have to clear them because they would interfere with our testing. Okay. Okay, we're going to go through the same process we always go through on these. We will start with this capacitor, and what we're looking at is the line going to this capacitor from the M92T36. This capacitor is connected through the M92T36 and onto the other side of the board to the Pi 3 USB, and this is the side we do not want to be shorted. To ground. Yep, we need to be on the right setting. Oh, we are on the right setting. Okay. Yep. Alright. And now we're going to be checking the lines from the capacitors to the M92T36. Generally speaking, if it has one line, we do not want it to have a pathway to ground. Okay, so we do have a short to ground on this line going to the chip. That should not be there. I keep accidentally running over there and hitting that one. Okay, so this is the only one that's short right now. This has two lines going to the chip, so one side will always be ground. I know which side to test though. And this is our CPU cap. Generally, if this one's shorted, it's not a good sign for the likelihood of fixing the switch, but it's fine. Okay, MOSFETs look okay. Check our little filter. Check our invincible fuse. It is still being invincible. Alright, now we want to check these test pads here. And none of these should have a pathway to ground. This one does. That's our M92T36 there. Okay, let's check around our BQ24193. Now the BQ24193 has several, or at least two capacitors with multiple lines going to the chip. As always, one side will always be ground. I know which sides to test. Okay, everything looks all right there. All right, next we're going to work our way around the Pi 3 USB. Now these filters can often have a manufacturer residue on them. You have to work your way through them. Don't let it troll you. It does appear that this filter may be blown. Alright, let's find ourselves a ground point and check our big capacitor around the Pi. The side we're checking is the line going to the chip, just like the other chips. Okay, appears to be okay, but it does appear we have a blown filter here. Yep, we're getting flat nothing out of that filter. Okay, so we definitely have a blown filter here and a blown M92T36 that we need to deal with. Let's prep those pads. We're just going to mix in some leaded solder here. That should be adequate. Okay, let's go about the process of removing this IC and putting a new one on. I will test after we remove the IC and make sure that short is cleared. Real quickly. Our short is cleared. I say real quickly because I want to get this on before all the heat dissipates from the board. Wetting the solder. We're looking for the center pad to melt. Okay, and we want to make sure it grabs the chip before we let go of the chip. Okay, looks centered. Let it dry for a second. Put some pressure on. Alright, I need to look and see if I have one of these filters. Okay, it does appear I have a small one. We're going to drop our airflow to 20%, like on the card. Try and throw this guy into place. We've mixed lighted solder in, so hopefully it will go in a little quicker. Okay, I think it's tacked down, so we'll bring the airflow now. Not afraid of it blowing off. Okay, now we need to start the cleanup and prepping for the new port. As always, we're just gliding here, and with the pads, we want to glide with the pads. These pads are not the strongest pads on the planet, so you don't want to be going crossways. Even if you're just gliding, you can very easily damage these pads. Alright, let's turn up our pads. Alright, let's turn up our port. No bridges, looks good. We'll just leave the flux. Okay, we'll approach this the same way we always do. We will rapidly move our nozzle. The goal here is to raise the temperature of the board enough to wet the solder. The solder that you can see and the hidden row of pins. While at the same time not ever being in one place long enough to burn plastic. Okay, the pins we can see are wetted. I'm going to go a little bit longer to make sure the hidden pins are. And we're going to press down and hold it down until we see these pins dry. I gave it a little while longer for the hidden pins just in case. Alright, we're going to do our little delicate nudge test. We shouldn't really get any play. And it feels very solid. If you have both rows going, you shouldn't get any play when you just tap it. If it's not solid, if you haven't gotten the second or hidden row soldered, you'll get a little bit of play. Alright, let's get our anchor points in place. You want to rub that in. You don't want to be nudging anything or putting pressure on anything. You just kind of want to rub it in on the surface. Let that heat climb up the leg. The solder will usually follow. And looking good. Okay, and if you'll remember earlier in the video, we were shorted on a test pad, so let's just make sure we're not still shorted. And no short. I believe our short was right there. And we'll just double check our M92236. Now we have a chip on there. Alright. Everything looks alright. I cleaned it off enough to do a test, so let's do that. Okay. What we're watching is channel PSU channel 1. We're looking at the far left one, amps. Okay, that looks relatively normal. And that looked relatively normal. So next, we will turn on channel 2. We will grab our modified iPhone battery squid. I'm sorry, you are not on screen. My bad. Plug that in and we will activate it with the OEM charger. And what we want to see here is a steady current increase. All right, that looks pretty good. Excellent. Not the end all be all, of course. We still need to see docking and all that fun stuff. But we're good enough to throw it back in the housing and put it together enough to do some testing, and we'll go from there. Okay, we're ready to perform a test with a charged battery. Okay, 0.47, battery symbol, switch logo. Okay, that's good. Let's check the other side. Okay, charging on the other side, fast charging, very good. All right, so that's all the testing I need to do with this. We're going to stick it, reassemble it enough to do, enough to charge on its own battery. And then I'm going to reassemble it enough to test the dock, because I'm curious about the dock with the filter replacement. I want to make sure it is working. So we'll be back when we're ready for that. Okay, excellent. You can see we're not having any problem docking, so now we'll come back and perform the rest of the test, but that was a primary concern of mine because we did replace that one filter. Okay, we're going to perform the rest of the tests here. First, starting with my Joy-Cons. I'm not seeing that one. Seeing one, we're not seeing the other. We have something going on in the connector. I do see some green stuff in there. Switch it back to microscope. I don't know if you can see it, but there is some green stuff in there. So I'm going to take apart the Joy-Con and have a look at that connector. Okay, we're definitely having problems in there and under the connector, so we got some cleaning to do in there. I'll start with my steel brush. All right. I'll stick it back in the rail and screw it back on, and then we'll do another test. Okay. Firing back up. Want to test that rail again. Kind of want to make sure we're not also having a fan problem. No, it's spinning up. Okay. Okay. They're going to need a new rail. I don't keep those on hand. That'll be up to the shop to deal with. But I will note that they need a new rail. All right. Let's check and make sure it's reading their game. And it is, as you can see right there. All right. So that's really it for this repair. So in summary, we had a pretty mangled up port. We took it apart, took the port off, did some testing. We found a shorted M92 T36, shorted on a capacitor and a test pad. We also found a blown filter in line with a Pi 3 USB. It probably saved the Pi 3 USB. So we replaced the filter, we replaced the dual filter, we replaced the M92T36, and we replaced the port. Everything's docking, everything's working, other than we have a secondary issue with the left-hand dock rail. I'm sorry, Joy-Con rail, and that's just something the shop. This is a business-to-business deal. That's something the shop will have to deal with. That's not really on me. So that's it. If you have any questions about the equipment I used in this video, take a look in the description below. They're all Amazon linked down there, and if you click on any of those links and buy anything there in that session, a small percentage of that will go to support the channel. There's also some other support links down there if you want to take advantage of those instead. If you like the video, do me a favor, hit the like button. If you want to see more videos like it, hit the subscribe button and the notification bell. You'll know when I post videos. And that's really all I have to ask of you. I appreciate you watching. I'll see you next time.